Okay guys, so today we're going to look at starting section 1.3, which is stoichiometry and gas laws and concentration. So it's just more math. We'll hopefully work through it slowly so that you can get caught up on the things that you might have not mastered last year, but make sure that you're reaching out if you are struggling with any of this. So what we're going to talk about today is just stoichiometry. So make sure that you remember that when a chemical reaction takes place that you're forming new substances. So what's happening is we're breaking the bonds of the reactants and then we're putting them back together, so forming bonds on the product side. And there's an energy change that happens. We'll talk more specifically about that energy change in our thermodynamics unit. There's a fixed relationship between the number of particles. So remember, law of conservation of mass. If we start with 5 atoms of hydrogen, we have to end with 5 atoms of hydrogen. So we need the reactions to be balanced. And then we can use those coefficients to relate their masses through the mole ratio. All right, so an example, we have the combustion of methane. And so this is one of the reactions that you have to be able to write without the pattern from the reference tables last year. So hopefully you know combustion is when you have a hydrocarbon like methane and it reacts with oxygen to form carbon dioxide and water. And then we would have to balance this reaction. So we have 1 carbon, 4 hydrogens, 2 hydrogens, so we're going to multiply by 2. 2 oxygens, and on this side we have 2 plus 2 oxygens. So we have 4 oxygens on the product side, so we would need 2 there to make 4. All right, so then it says calculate the mass of carbon dioxide, so we're looking for the mass, of 1 gram of methane. So we're starting with 1 gram. So we're just going to set up our stoichiometry. So we have 1 gram of CH4. We bring grams to the bottom. And before we can do anything, we have to be in a mole. So we're going to change that unit to mole. And if we're changing the unit, you can't change the substance. So notice the CH4 is the same, but the unit is changing. And then we put 1 mole on the top, and we put the molar mass of methane on the bottom, which is 16.05. We would multiply and divide, and the grams would cancel, leaving us moles. But we don't want information about methane, we want information about carbon dioxide. So this is where we're going to set up our mole ratio. So we put moles of CH4 on the bottom. And this is the only time that you're allowed to change your substance is when you're doing a mole ratio. So this time our unit stays the same. We're going to change the substance. So we're going to go from CH4 to CO2. Again, can only happen when you're in that mole ratio. And then you use the coefficients, 1 and 1. Mole cancels. We're at moles of carbon dioxide, but we want to know grams of carbon dioxide. So we're going to do one more where we switch that unit again to to grams. So from moles we can go to grams, and then we have 1 mole, and then the molar mass is 44.01. The moles of CO2 cancel and we're left with grams. So then we just have to type it in. So 1 times 1 divided by 16.05 times 1 divided by 1 times 44.01 divided by 1. And the sig figs for our answer is based on the given substance, which is the 1.00. Those zeros count because they're after the 1 and there's a decimal. So our answer is going to be 2.74 grams CO2. In the scheme of things, this is a easy stoichiometry problem. It can get more complicated when we start talking about limiting and excess reactants. So when you have information about 2 or more reactants, then you have to think about limiting reactant. So the limiting reactant is the one that runs out during a reaction. The excess you have extra of, so you have some left over. And the theoretical is how much you should be able to produce using that given information. So in our problem here, we're making a sandwich. We have to use 2 slices of bread, 3 pieces of lunch meat, and a slice of cheese. So if we have 6 pieces of bread, 12 lunch meats, and 5 pieces of cheese, how many sandwiches can we make? Well, putting them together, we can make 3 sandwiches. The bread limits the number of sandwiches we can make, because once we use up all 6 slices of bread with our 3 sandwiches, we can't make any more. So bread was a limiting reactant, and the lunch meat and cheese are the excess reactant. In fact, we can figure out how much excess we have left over. So after we make our 3 sandwiches, we still have 3 pieces of meat and 2 pieces of cheese. So this is how much is left in excess. This is how much we have extra of. All right, so we are going to be using that concept. It's just we're not making sandwiches. So the steps to determine the limiting reactant, you have to have that balanced reaction. You have to be in moles. And then you're going to compare the moles to figure out which one you're going to run out of first. Then you can use your limiting reactant to continue solving any of the other questions that might be associated with that problem. All right, so here's our example. We have 18.1 grams of NH3 reacting with 90.4 grams of copper oxide. So notice we have information about ammonia and we have information about copper 2 oxide. So we have 2 givens with reactants. So that's a limiting reactant problem. That's how you know it's one. And then what we're asked is to determine the mass of nitrogen. So we want to know how much nitrogen we can form. There's various ways of solving this problem. And if you Google and try to watch other people's lessons on limiting reactant, they might show you different ways. I'm just going to show you the way that makes sense for me. If you watch a different way and that makes sense for you, by all means use that. As long as you're getting the right answer, I really don't care. So the first thing that I want to do is take my grams and convert them to moles. Short one step, grams of NH3, moles of NH3. And then 1 mole and is the molar mass. So that would be 17.04 grams. And then we can multiply and divide. And we get, keeping our sig figs, 1.06 moles of NH3. And I'm going to do the same thing with the copper. So 90.40 grams of copper 2 oxide. 1 mole of copper 2 oxide is how many grams of copper 2 oxide? So add the molar masses together. And you get 79.55. Keeping the sig figs, 1.136 moles of CuO. All right, and then in our head, we want to divide by the coefficient. So in my head, this number divided by 2, and then over here, this number divided by 3. Which one is going to give you the smaller amount? So if you need to type it into the calculator, you can, or you can do it in your head. This divided by 3 would give us something along the lines of 0.337, and over here this would give us along the lines of 0.53. So this is the smaller amount. So that means that CuO is my limiting reactant and NH3 is my excess reactant. All right, now I need to actually answer the problem. So I'm not using the stuff that I wrote in black. I'm not using the stuff that I've put in my head. I'm using what's in red. So I start with my limiting reactant. As soon as I figure out which one is going to limit the amount of sandwiches I can make, that's what I'm going to base my answers on. So I'm starting with my 1.136 moles of CuO. Notice that I didn't go back to grams, because if I went back to grams, I'd have to do this converting to moles again. If you want to, that's fine. You don't have to. Once you're in moles, though, you can go from moles of copper to oxide to moles of nitrogen. And based on our balanced reaction, the coefficient for nitrogen is 1, and the coefficient for CuO is 3. So moles would cancel. That would give me moles of nitrogen, but we want grams of nitrogen, so we're going to go one more time. 28.02 grams of nitrogen. So moles would cancel. So we're going to take our moles of CuO, divide by 3, and then multiply by 28.02. Keeping our sig figs, we have 10.61 grams of nitrogen. So there's my answer to part A, and then, or part 1, and then I have to figure out part 2. So determine the mass of the excess reactant left over. So this is like we've used up all of our bread. How much cheese would we have left if we made that many sandwiches? So what I have to do is I have to figure out how many grams of ammonia I used and then subtract it from the 18 grams that I had to begin with. So again, you start with your limiting reactant. So if my limiting reactant runs out, how much NH3 would I use? So we're going to set up that ratio. So coefficient, 3 moles of CuO, coefficient, 2 moles of NH3. But we want it to be in grams, so then we're going to convert that to grams. So 1 mole is 17.04 grams. So the moles cancel. And then working that problem, times 2 divided by 3 times 17.04. We've used 12.91 grams of NH3. So this is how much we've used. So we have 18.1 grams. We used 12.91 grams. So we're going to subtract, and that will tell us how much we have extra, how much was left over. So 18.1 minus our 12.91. When we subtract, we want to use the fewest decimal places, so we're going to round that to 5.2 grams. So there's my answer to part 2. 5.2 grams in excess.